I'm going to get started if that's okay. Hi, everyone. I'm Nick Valentino. I am an assistant director in the Hajim School of Engineering and Applied Sciences Dean's Office. I've been at the University of Rochester for over 16 years. And if you can't tell by the way I say the words cat, dad, or accent, I am a native Rochesterian. We have others on the call who will be answering your questions today via the chat. I'm going to talk about how to submit questions a little bit. But first, I'm just going to call on others to introduce themselves. We could start with, how about we start with Dean Funkenbush? Do you want to start, Paul?
Sure. Hi, Nick. Hi, everyone. My name is Paul Funkenbush. I am a faculty member in mechanical engineering and currently the associate dean for the Hajim School.
Alvin?
Hi, everyone. My name is Alvin Lamibal. I'm the Assistant Dean of Undergraduate Studies, which means I'm responsible for our undergraduate programs team, which includes advising and student engagement and outreach. So I'm happy to be with everyone here today.
Kelly?
Hi, my name is Kelly Johnson. I'm an assistant director in the Hajim School Dean's Office. So I help with transfer students as well as incoming first-year students.
Hannah?
Hi, everyone. My name is Hannah Goldstein, and I'm an academic advisor in the Hajim School, and I work with mostly computer science students. Nice to meet you.
Great. And Sonia?
Hi, my name is Sonia Hamid. I'm an academic advisor for Hajim, and I work mainly with mechanical engineering and optics students, and I'll also be spearheading the engineering science students too.
Great. So as you can see, we got a bunch of people to stay late on a Friday afternoon because we want to let a little bit more about the Hajim School, about the University of Rochester, what it's like to be an engineer or computer science student. And as you may have heard me say, the engineering school is pronounced Hajim, the Hajim School. The school was named after after Ed Hajim. Ed is a graduate of the University of Rochester. He was in chemical engineering. He participated in Naval ROTC. He was a Wall Street executive. He is very much alive and well, and has published 2 books. So moving on. The purpose of this presentation is to give you a very high-level intro into engineering and the types of opportunities that you'll have. This presentation is designed for people who have no background on engineering or in Rochester or the University of Rochester. The reason being that you don't require any additional training or coursework in high school to become an engineering student at the University of Rochester. So, when you get accepted to the college, engineering is an option. Just some housekeeping. We want to remind you that we're recording this presentation so we can post on our website for those who are unable to attend, or so that you can revisit it. If you'd like to ask a question, please submit it through the Q&A function located at the bottom of the screen. The panelists are going to answer as many questions as time allow. We're going to be doing this as I'm talking too. So if you have a non-related question, it's okay to put it in the Q&A because we might be able to answer individual questions for you. At times, we might have a bunch of questions that are very similar, so we might answer it live. So we'll stop the presentation and then go live to talking about the question. If you'd like to view this session with closed captions, click the CC in the bottom of the toolbar and select Turn on Subtitles. If you're having any trouble viewing the webinar, you can call in and listen using the phone number that was included in your confirmation email. There you go. So first, we'd like to acknowledge with respect the Seneca Nation, known as the Great Hill People and the keepers of the Western Door of the Haudenosaunee Confederacy. We will take this opportunity to thank the original caretakers whose ancestral lands the University of Rochester currently resides in Rochester, New York. All right, the agenda for today. The presentation I have is about the University of Rochester from the engineering and applied sciences perspective. So the way that I'll talk about academics, student services, co-curricular opportunities we'll have in engineering and applied sciences been. That being said, we know that for many of you, this is your first introduction to the University of Rochester, so we're happy to answer more questions generally about the university. All right, what is engineering? I want to start with what is engineering because many students don't have access to engineering in high school. And I want to make sure that we're all on the same page. Using a very basic definition from the National Academy of Engineering, engineering is the creation of technical solutions in the interest of humanity and society. So this definition has three components. The first is creation, which really tells us that engineering is about making, inventing, or problem solving. The second is technical solutions, which is distinguish engineering outputs from that of art or journalism, et cetera, which is also creation. And then finally, there's the interest in the interest of humanity and society. Engineers do what they do so that they can make our world a better place for others to live. There's a more elegant or romantic definition that we really like. It's from the Japanese film director Hayao Miyazaki, which is engineers turn dreams into reality. So we're talking about comparing engineering to that of the field of natural sciences, which seeks to describe and understand natural phenomenon. Some of you may be wondering how this compares to these fields like biology or chemistry or geology or physics. Those are natural sciences. And in general, these subjects are interested in describing and understanding the world around us. It requires creativity, ethics, critical thinking, and leadership. So engineers and computer scientists do not work alone. They work with others in teams. So some context about what makes an engineer or a computer scientist: you must have good critical thinking skills, creativity, ideation, innovation, ethics and integrity foremost, and in leadership. Another way to consider what engineering is through the kinds of problems that they seek to explore. Engineers are problem solvers. To do this, we use the lens of the National Academy of Engineering Grand Challenges. So the Grand Challenges are Grand Challenges for Engineering were announced in 2008 as the biggest goals for improving life in the 21st century. With these problems in mind, the University of Rochester goal is to graduate students ready to address these problems, which are among the most complex, interdisciplinary, and interconnected problems that society faces. So I'm going to give you just a second to read these. Take a sip of water. As you can see, they fall under four themes: making our world more sustainable, healthy, secure, and joyful. We like showing the grand challenges because they are interdisciplinary problems with a lot of different pathways to start solving them. Like, for example, if you look at the bottom right, you're going to see the Perseverance rover. That falls under engineer the tools of scientific discovery. But in order to create the Perseverance rover and get it to Mars, the project team needed mechanical systems. So including whatever is needed to launch it from Earth, fly it to Mars, then the entry, the descent, the landing system, and then whatever's needed for the mechanical, chemical analysis on the surface. It also needed electrical components and systems such as sensors to support all aspects of the mechanical systems. And they have to be able to see, so they needed optical requirements needed to be met, including cameras and other lenses. And of course, it needed plenty of computer scientists. And as you can see, it's a ton of interdisciplinary work. So if you're unsure about your intended major, you can look up NAE Grand Challenges. It's a site on the internet. If you're unsure, see if it lines up with the grand challenge that interests you most. You're going to be looking at these. Some of them are going to be identifying to you. Let's say, for example, you're looking. You see, okay, securing cyberspace. I am interested in that, and you're also interested in being an electrical and computer engineer, or maybe a computer engineer or a computer scientist. You're probably on the right track. If your favorite challenge is securing cyberspace and your intended major is chemical engineering, well, it might be worthwhile to investigate this some more. And it also helps if you're looking at how to solve problems rather than trying to figure out the coursework and the jobs that come after this. First, think about what problems you want to solve, and then which engineering you might want to go into. So this is what we offer. Perhaps the most direct way to study engineering and applied sciences at Rochester is through a major. We offer 11 majors, and you will be given more info on these about these department information sessions through admissions. So this is the only exposure you're going to get to this. Well, we don't limit studying engineering and applied sciences to just majors. In fact, many students who end up graduating with majors in arts and sciences learn engineering and applied sciences through a lot of stuff I'll talk about after this slide. So to give you an example, some of the related majors in arts and sciences could be archaeology, technology and historical structures, data science, and digital media studies. So this is to say, we understand that you might be interested in engineering, but you're also probably interested in a whole bunch of things, and we have to see where the intersections of those are. So some of you may have been looking at the asterisk and wondering what ABET is. ABET stands for the Accreditation Board for Engineering and Technology. It's an international board that offers accreditation in individual academic programs in engineering, computing, technology, and applied sciences. So accreditation by ABET is the assurance that the alumni of that undergraduate program meet the quality standards in that profession, as outlined by practitioners and professional societies in that field. It sets students on a great path to become practicing licensed engineers. So the question we always have is, why are they not, what are the ones starred that are not starred? I'll take computer science, for example. The computer science department feels that, that they understand the curriculum and the things that you need to be a practicing computer scientist. So it's not all the majors that want to go under accreditation. There are other standards they have to follow. So just because something is not necessarily accredited doesn't mean that it wouldn't produce you to work in the field or a job at the end of that. I am going to pause right now to see if there's any outstanding questions that haven't been answered. It does not look like it. All right. So perhaps you have an interest in some of the areas I mentioned, either on the grand challenges slide or on our list of majors, but you have a competing interest and you're not sure you want a full major in engineering or computer science. So at Rochester, we do offer a number of options to study engineering or computer science that don't lead to a degree. The minor. A minor is a pre-approved set of courses in a given field. It's usually 5 to 8 courses. All of our academic departments that offer at least one minor in the Hajim School. It's fairly common for students who have a major in one of the engineering majors to find space for a minor in another discipline. So because we think that technical exposure and experience is important for all students. In the past few years, we've tried to come up with some of the interdisciplinary clusters that live in the Hajim School, but have components of humanities or social sciences as well. So you may have some background in the cluster system, the idea that you'll take these interrelated courses. So if you decided you want to do something in arts, in sciences and not engineering, you'd still have the opportunity to take engineering coursework if you were interested in it. So for example, there's a engineering and technology in antiquity. It's a popular cluster that can have a study abroad component. We've had a field school in Ghana over the past few years. If you look to the top right, that's the field school in Ghana. Students explore the engineering, historical, and cultural aspects of a dozen coastal forts in Ghana. There's also like green energy management. This could be for students who are interested in the intersection of business or marketing and sustainable energy. So again, the audience for these clusters are students who will have a major in the arts, humanities, or social sciences, but are looking more for a structured introduction to one of these areas that are broadly within the field of engineering, optics, or computer science. Finally, if you don't want a full major or minor or cluster, we do offer about 15 introductory courses in engineering, product design, fabrication, computer science. And these courses are open to all undergraduate students enrolled at the University of Rochester, including Eastman School. They have no prerequisites, and I'll have a list of them in the next slide. I'll give you a chance to read this. There are a combination of full credit classes, which is 4 credit hours for us, as well as 2 credit courses. So this often can be in addition to existing class load, or if you want to get more hands-on work for some of the courses, especially things like basic mechanical fabrication is working in the machine shop, intro to CAD, the computer-aided design, intro to computer science. So there is opportunities to take engineering courses if you're not interested in a cluster, a minor, or a major. All right, if I'm undecided, how should I plan my first year? It's okay to be undecided. There's a lot to choose from. Your academic advisor will help you find the balance of the foundational knowledge and exploratory courses. So most intro courses are common between majors. At any point, you are free to change your intended major. Some schools have restrictions on this. We do not. So if you look at the bottom, let's look at the fall. You're going to have the intro Hajim course. So it's going to be, either audio and music engineering, biomedical engineering, chemical engineering, electrical and computer engineering, mechanical engineering, or optics. They all offer introductory courses so that you can get a sense of this is what you want. A lot of these courses are not required. So if you start out in something like optics, but then decide that you want to do mechanical engineering, we're trying to make this as seamless as possible because we understand that people's minds are not completely made up when they get here. As you see, the second one is math, right? You're going to take a math your first semester. You're going to take the calculus series, and there are additional math courses beyond that. I know some of you have taken pre-calculus. Sometimes you have the opportunity to go past those with AP or IB credit. We'll talk about that a little bit later, but essentially you're going to be taking math. A science, because it depends on which discipline we're talking about, what your science is going to be. And then you take either the writing the first semester or the second. You have to finish it before the first year. Everybody at UR takes the writing course. The only exception is for transfer students who have taken an equivalent course elsewhere. So the one thing you cannot get around is writing 105. That's okay. There are a lot of different options for writing 105. They could be 4 credit, they could be 2 credit over 2 semesters. We understand everybody comes in with a different comfortability with writing, but it is going to be done in the first year. So when you get to that second semester, and if you have decided that you've changed path, we want to make it so you don't have to spend additional semesters here just because you changed between the first and second semester. Can you change to another semester in your second year? It's possible, but it gets nuanced, and I'm going to talk all about advising in a little bit, which you will get plenty of. So I do want to highlight a few curricular options for you. Sorry, hold on, give me a second. I went too far. There is the CASC 104, which is called Designing Your Life. So you're going to get credit, get course credit for determining what you want to do in your life. You have an instructor who's a professional at the college that will talk about all of your options, especially if you're unsure. We're going to ask you to go with your best guess on what you want to do first. But a class like CAS 104, Design Your Life, it really plugs you into the resources that you have in the exploratory tools that you have at the college. As I said before, writing 105 is required. There are many different topic options. Some of our engineering and computer scientists are not fond of writing. So at least you'll have this section. So if you're not fond of writing, fine. You have this section, you can at least write about engineering, which is hopefully a subject that you would feel comfortable writing on. We're trying to give you more options because we believe there's a writer inside of everybody. It just depends on what type of writing you're going to do. I am going to take a pause. Do we want to answer any of these?
Sure, Nick, there's one just asking, I don't know if you're going to go over it in more depth in future slides, but someone wanted to know a little bit more about interdepartmental engineering.
Yes, I will talk about interdepartmental engineering in just a little bit, but there's 2 things that I want you to think of. Is interdepartmental engineering is a specific major, whereas taking courses from different departments is something different. So interdisciplinary is different from the interdepartmental.
And then the other one, I don't know, Paul, if you wanted to answer this, or Nick, if you want to talk about it, but there was a question about general student to faculty ratio in specific engineering classes and how accessible professors are for academic support.
I know at the college it's 9-to-1 is the student to faculty ratio, and I'm not sure about Hajim. I would imagine it would be less. But
I don't know a specific number for Hajim, but in terms of class size, the introductory science classes and math classes where all the engineers take them along with lots of the natural science folks, those are quite large classes. So those could be 100, 200 students, but that will be broken down. So there'll be a large lecture, but then there'll be smaller classes, recitations where there's a chance to interact more with an instructor at that level. Once you get into the major, so if you're taking a mechanical engineering class or a biomedical engineering class, typically the class will be all the students at that year level in that major. So for example, all the second year students in mechanical engineering, almost all of them will be taking dynamics, ME 121 at the same time. So the class size is largely determined by the number of students in the major at that time. And again, typically there'll be a large section and then that will be broken down to smaller sections. But just to use mechanical engineering as an example, typically there's maybe 60 students per year in mechanical engineering. So a typical dynamics class will have 60 students in the class at any one time.
Yeah, and we're going to talk a little bit about like recitations and study groups, and the idea that you're going to be starting engineering. So you start as a biomedical engineer with the same group of students that you're going to move up with. So you're going to have these smaller and smaller groups that you'll be able to lean on because we don't do this alone here. See if I want to answer any of these.
Okay.
I was thinking, please talk about how interdisciplinary research works. For instance, CS and biology are encouraged and facilitated. So there are two most common ways that students will address something interdisciplinary. One is the more sort of, I guess, high school mentality, and the other one is the college or university mentality. The high school idea is I'll take more courses because that has been the solution, right? I've taken all the hard courses. I will take even harder courses. I will take AP courses. I will take college credit courses, which is fine. We have that option for students. There will be prerequisites to things, but at the same time, you have the opportunity to do it. The other way is through research. Our biggest strength as a college, I believe, is that we're a research one institution, and pretty much all of your faculty are working on research. So you'll be able to understand the interdisciplinary parts of this by having a better understanding of what your faculty research is about and trying to find somebody who has those interests between the intersection of those things. So there are formal ways like taking a course or even having a research position, but part of the best conversations that I have heard from students is just being able to talk one-on-one with faculty who are doing the work that you're interested in as well, and having that accessibility. So you will have opportunity to, but really the best way is facilitating some of these conversations.
So there's one question which I can answer live. Amelia asked if there are sort of a basic introductory course during the first year. And the answer is yes. Every department has an introductory course, which is intended to be sort of an introduction to that department, but also a more general introduction to engineering. So in mechanical engineering, we have something called the Bridges course, where students learn how bridges are constructed, and they go out and kind of see some of the local bridges, and there's a little bit of history associated with it too. But in addition to sort of the mechanical engineering part of that, it more generally introduces what's engineering about, how do you design things as an engineer. And so most of those courses are interchangeable. So if you came in and you said, I think I want to be a mechanical engineer, but maybe I want to be a chemical engineer, you could take either of those introductory courses, and then you could decide halfway through, I'd rather be a chemical engineer, and you'd still be able to count the mechanical engineering course towards your chemical engineering degree because it's an introductory course.
Great. I'm going to answer some of the stuff about industry a little bit later. So we're going to move on for now, and then we're going to answer some more questions. The Grand Challenges Scholars Program. So I talked a little bit about the Grand Challenges in general, but the University of Rochester actually has a program where you can explore these problems and challenges in greater depth. So over the course of your time at the University of Rochester, you can complete your degree. And then on top of that, you can be recognized by the college as a Grand Challenges Scholar by choosing one of the Grand Challenges and then completing 5 different kinds of experience around that challenge. So you might choose, provide access to clean water, or engineering better medicines. Your experience relate to a theme. This is like an umbrella so students who join the program, they typically join the program in the second year by proposing a set of experiences around one of the Grand Challenges. So you pick a challenge, you have these different experiences. One of them is research. So you'll do research on this. You'll do some sort of interdisciplinary experience, something related to entrepreneurship or innovation. There's a global dimension to this, the idea that this will affect the world, and service learning. So you don't actually even need to major in engineering or applied sciences to be in this Grand Challenges Scholars Program. We have students who graduate the program with degrees in business analytics, brain and cognitive sciences, political science, economics, and digital media studies. So on our website, we have profiles of the students who have participated in this program. So if you go to the UR site and type in Grand Challenges Scholars Program, or if you go to the Hajim site, it's one of the tabs at the top. This is an example of the idea of something that is both interdisciplinary and also using the different resources that the colleges offer at the same time. And the good part is that there is a capstone programs that are they're recognized during the Melior weekend, so you get recognition for this at the end. all of this is sort of to discover where you want to go. So we want to talk about exploration. There are other ways to explore, what you want to do and your field and your academic path. You can get exposed to research. We are a Research One school, as I said before. Most of your faculty will be working on research. You'll have the opportunity to speak one-on-one with them and possibly visit, and in some cases, work in their labs. It is not uncommon for undergraduates to be able to participate in research. As we speak, we'll talk a little bit about internships. As we speak, major specific internships opportunities are being compiled by the Career Center to help you with your search. So they're doing a lot of your legwork by putting all of these opportunities in one place for you, so that you can see what options are out there. We do have students do internships. It's quite common in the engineering and in computer science. We also have students who will do an internship 1 year and then perhaps do a REU, which is a research experience for undergraduates. The idea that you spend a summer doing research, just to get a better perspective of what you might want to do. And these are both options, either through the college or just applying to different opportunities outside of the college. There are also global experiences, both traditional study abroad, as you think of it, like in terms of like a semester, as well as shorter experiences, which could include like 4 or 6 week summer experiences, or even 1 to 2 weeks during the winter break. There are plenty of student organizations, either through your major. There's also affinity groups like the Society of Women Engineers, the National Society of Black Engineers, Society of Hispanic Professional Engineers. There are hands-on groups like Solar Splash, which create a solar-powered boat and then travel to an annual competition to race it. We also have a robotics group. We have Engineers Without Borders. You're going to have a lot to choose from. In terms of entrepreneurship, you can get direction from entrepreneurship at the AIN Center. The AIN Center educates the university on developing and applying an entrepreneurial mindset. So you might have ideas, but not really know how to apply them. The AIN Center is an option for you to visit during your time here. We also have community engaged learning. It's going to combine the teaching, research, and the practice with 1 or more partner organizations in the Rochester area that will provide students with meaningful opportunities to connect their learning and civic identity. So this allows you to learn more about the issues facing our communities locally, as well as regionally and nationally. So major declaration doesn't take place until sophomore year. You can use experience in these areas to help determine, where you think you want to go in terms of your academic path. After doing some of this exploration, you might still be undecided on which engineering to take. That's okay. We have a few options for you. The first is engineering science. This BA, engineering science is a BA degree. It provides a flexible and interdisciplinary engineering experience for students who wish to broaden their learning horizons across disciplines in the liberal arts. Its mission is to educate students to develop and convey solutions to multidimensional problems that require scientific, technological, global, and social perspectives. The engineering science BA, it provides a strong background for students who wish to pursue careers in technical sales, public service, management, entrepreneurship. It is designed with students in mind who may be interested in being able to be conversant with technical folks, but not necessarily the ones who are doing the day-to-day engineering. So you might want to work in the field of engineering, but you don't necessarily want to be a day-to-day engineer. And the engineering science degree offers you both the problem-solving training that you'll get, while also get the familiarity with the industry. We've had students, it's prepared them for a wide range of jobs in government, private consulting companies, a variety of major industries. Graduates have had success in admission to graduate schools in medicine, law, business, education, and social sciences. So you may have heard of a Bachelor of Engineering. That's more common outside the United States. Engineering science is a different degree. A Bachelor of Engineering is more of a professional degree, whereas engineering science is a liberal arts degree. I want to show you, this is some of the coursework the foundational parts that I discussed before. These are the parts that you'll learn that are requirements through the curriculum. So there are optional focus areas. They are optional because we design them so that you'll have the means to create a track or a focus area if you have a degree of specialization that you want. So these courses would lead you to a more in-depth understanding of a particular topic or possibly a minor. Notice the word optional is highlighted. Students are not required to follow these tracks. We all have sample schedules of these in the website as well, but these are some ideas where how you could direct engineering science. The ES curriculum, as you can see, despite it being a BA, is all science courses. So I don't want the BA to throw you off. It will be all science courses in engineering science. We had someone ask before about interdepartmental engineering, or IDE. Engineering science focuses on engineering as applied to arts and sciences, and the interdepartmental engineering program requires more technical courses and technical sequencing of courses that achieve the student's educational objectives. So recent technological, economic, and social developments have significantly extended the range of problems to which engineering skills and methodology must be applied. Problems in environmental quality, transportation systems, housing, and urban planning, among others, challenge students to develop programs combining technical knowledge with social and political awareness. Additionally, the growing complexity of our technological society requires some engineers who have integrated studies in several technical fields. So examples of this are high energy density physics, or AR/VR. We know that students may have a specific idea for a type of engineering that we do not offer. In interdepartmental engineering potentially is an opportunity for you to be able to get your education here to fulfill some of those areas of study that you'll need to understand in greater depth. I want to talk about the curriculum. So the interdepartmental engineering major requires that students also complete 3 sequences of technical courses of their own choosing. And students must complete an independent study project that culminates in a senior written thesis or design project. Here are some of the sample IDE programs. Interdepartmental engineering students are less common. As students find that their existing major and minor combinations are often enough to get them where they want to go. So robotics, it combines some electrical, computer, and engineering in computer science. But students often find that they're interested more in software than hardware, and they may choose computer science and then minor in electrical and computer engineering, or vice versa. If they're more interested in hardware, they may minor in computer science. So we have fewer students do the interdepartmental engineering major because the majors that we offer and the minors that we offer are so robust that doing a separate program in interdepartmental engineering doesn't end up being what they eventually want to do. So while IDE might suit your engineering interests, it is a very challenging workload that mirrors other engineering major requirements. So just to sort of compare the two, I'll leave this up. I'm going to pause for questions just so you can see the differences between engineering science and interdepartmental engineering. We could talk about industry partnerships or collaborations that the engineering program has that will benefit the students. It depends on the major. In optics, they do have a program where they will bring in different companies in industry to be able to bring the options to the students. We have a lot of work through the Career Center in which we consistently get students who get internships and employment from after. In terms of, if you're asking about like a co-op, we don't have a co-op built into our program. You would have the opportunity to do a co-op. As an undergraduate, it's essentially you would be taking a leave of absence and be going and doing it. It's not specifically plugged into a program. It is great experience. It is really getting you immersed in the life of industry and knowing if this is a direction that you want to go. But we do not have a formal co-op program that's built into any program. I've been looking into the Society of Women Engineers Club and found it very interesting. I'm wondering if there are any requirements to be part of some particular clubs at Rochester. There's really not a lot. I think a lot of it is the idea of they will permit you to be in the club and participate. How much you are able to participate is dependent upon typically what year you are in as an undergrad. Students typically get in there and they try to participate their first year. Their second or third years, a lot of times they'll take a position on the board. Every student organization has a board of people that are the vice president, president, community chair, fundraising chair, conference chair. They have different jobs in each. A lot of time, your second and third year students will take a position in there. So there's not a lot of requirements to be able to do this for a lot of the engineering groups. Even you don't even need to be an engineer. You just a lot of students will start in engineering and decide they want to go elsewhere, and we encourage them to still participate in these groups because they're a valuable experience for undergraduates to have.
Nick, let me jump in there just real quickly to add to that. So the groups like Society of Women Engineers, American Society of Mechanical Engineers, again, anyone can join those, and that's actually fairly typical. Most universities will have that. What does distinguish us a little bit is groups like Society of Grand Challenge Scholars, for example. A lot of schools will have restrictions on that, so you will not be able to participate. Not everyone can participate. They'll have a screening process, and only some students will be selected to participate. Baja is another example. Some schools that have Baja programs, only some students can participate. We're kind of distinguished a little bit in that area because we essentially allow anyone to participate. So if you come here and you want to be involved in the Baja group, or you want to be involved in Grand Challenges, or you want to be involved in the Lunabotics, essentially everyone is welcome, even non-engineers. So we are a little bit distinctive from a lot of schools in that regard.
Yeah, and I think one of the biggest differences between high school participation in student organizations and college is in high school, you're demonstrating the breadth of knowledge and experience and involvement that you have as to demonstrate that you're able to get into college, right? You're saying, look at all these things I'm able to do. I'm able to multitask. I'm able to have a role in all these organizations to demonstrate that I am, it's going to help me get into college. Whereas what we're hoping for a lot of the groups we talked about, it will help narrow down your interests within engineering to get more experience to what others are doing and what other options are. And for a lot of them, it's just to really get experience in all the other stuff on college, in the college campus that you would be able to experience, right? So if you can think of something, we probably have a club for it. My last count, we have somewhere between 70 and 75 a cappella groups. It feels like, I know there's only like 5 or 6, but it feels like there's a lot more. We have all of these opportunities both in and out of engineering for you to do, to develop your interests and to be able to narrow down what your academic focus is, and just to meet people and have fun. The idea that these groups don't have to count for something. They just might be, the times that you're not in class, you're going to be filling your life with other things. And we do want you to get involved in student groups. Can you give an overview of college life of an engineering student at the University of Rochester? That is a great question. I'm trying to think of where to start. I think that one of the common things we see is a level of uncertainty in the beginning, where getting exposed to what you think that you want to do. For a lot of students, it's affirmed. We don't get a lot. The majority of our students stay where they are and finish in the degrees that they start in because they have a good general sense of this. It is math intensive, and math is one of, if not the most important things. If you have a strong like of math, I don't want to say love, because that means different things. If you really, really like math and you feel that taking that math and applying it to solve problems, if you're really interested in physics and you want to use physics to solve problems, I think a lot of your first year is determining if those things are true, you like those things, and really start getting involved in different experiences to see if this is the major that you want to do. Once you get into the major, it is this subsection of the student body and community that you're going to have all this interaction with. So you're going to have this little world, let's say for mechanical engineering, where you're going to start meeting faculty and other upper class students who are involved in this and are already going places. So you're brought into this world that you think that you want to join and do. And every single semester you get better, right? You're able to, even though the classes get harder, you're able to finish things with a better understanding of where the resources are. It's less and less certainty in terms of this is what I want to do for the first few years, and that translates into the uncertainty of where am I going to go from here. So it can be difficult, but the bottom line that we want to get in terms of from our perspective as advisors is that if there is a problem, you will have someone that you can talk to about this. And who that person is will depend. And I'll get into advising in just a little bit. So the most important aspect of that is that it will be confusing and difficult at times, but you will not be alone. And that's one of the things that we want to do in terms of the dean's office.
Nick, really quick before you move on to the next slide, can you clarify if a student does do the Bachelor of Science in Interdepartmental Engineering, what that looks like on the diploma and the transcript?
I'm not 100% certain. Like I said, we have had one interdepartmental engineering graduate in the past 4 or 5 years, I think, to the point. So I will look up the answer to that. I think it would say interdepartmental engineering. I'm assuming it has topic, but like I said, we have not had one in a long time because of that. All right, I'm going to go to the next slide. All right, so I talked a little bit about this, how you're not going to do this alone. This is a lot. You might be thinking, am I prepared for this? How do I navigate this alone? You don't. There's no expectation or requirement that you have had an engineering and applied sciences background before coming to the college. I talked about that a little bit before. Many students do not take engineering or computer science in high school or bring in AP or IB credit. We care a lot about your success in the first year. We care a lot about your success in all 4 years, but especially the first year as you navigate through your options. We have a tiered advising model, so you'll have different advisors for different areas, which I'll get into in a second. Large classes also have tiered learning through smaller workshops or recitations. So I think you heard Paul say recitation before. Recitations are like a professionally guided study group, so that you can ask more questions in smaller groups outside of the actual lecture. We also encourage students to join or create formal or informal study groups. Because we have found if you get closer to the people that you're have the same major as you, you're able to do this together. We also do checkup points throughout the first year, especially to see how you're doing and to see if you need to make any changes or if you're changing direction in your academics. We put a premium on your learning outside the classroom. So our office does take pride in the pre-professional societies, like I said before, like the student groups, affinity organizations, design groups. They're going to help you find your community and explore engineering outside the classroom. So you're going to also have some degree of access and opportunity to the listed institutions that are on the bottom there inside the university. One of the most popular one is a laboratory for laser energetics. We have a laser that is federally funded and state funded. You may have the opportunity to either visit there or potentially do some work there. I don't think they'll let you fire the laser until you get really, really senior. So we might have to hold off on that. Just remember, you don't have to learn all of this now, but we're not going to let you do this alone. All right, you're going to get a lot of advice. You're going to get a college advisor. Let me go back. You're going to get, if you choose engineering, you're also going to get a faculty advisor and help from an undergraduate program advisor. You're going to get advice from professional advisors, such as those in the Career Center, the Financial Aid, Office of Minority Student Affairs. Your fellow students are going to also be advisors. We have peer advisors, we have peer career advisors, we have resident advisors who will live in the residence halls with you. Point of clarification, we call them residence halls here. Dorms are the actual rooms that you sleep in. We have first-year fellows, and we have peer health advocates. So you're going to find a lot of answers to questions from a lot of people. This is too much information for now. I just want to let you know that help is available. If you want to learn more about any of these services, advising services is going to connect with you to get more of these. Advising service, CCAS as it's called, is going to have a separate presentation that you'll be able to attend about advising services. I like this graphic because it really does depict that this is more than a classroom. The college is much more than classroom work. The solution in high school, as I was saying before, is often take more and harder courses. Now the solution is to leverage the resources of the university to help you find your academic and career path. So all of these options contribute to helping you discover who you are and what you want to do and what you want to be. So remember that some efforts won't get you credit, but they will give you perspective. So where does this all lead? I'll do some career outcomes for us. I know most of you are aspiring scientists, and we like to look at data. So I'll have some data to look at. I'll leave this up for a minute. A few things I want to highlight. This is self-reported from students. You're going to have the opportunity to join something called the Meliora Collective. It's a platform that provides a way for the University of Rochester community to come together and explore opportunities for personal and professional development. In the Meliora Collective, you can make meaningful connections with people in your field, region and industry. You can improve and strengthen your network with special access to the University of Rochester community. It's more defined through filters. It's more defined than filters in something like LinkedIn. So you can find and expand your interests. There are dozens available by academic focus, athletics, and industry. So the Meliora Collective is essentially the way that you're going to get plugged in to the big network of UR grads. So we're asked a lot by parents as well as students, what happens after you graduate, what students are doing at their companies. The list is growing as our students report more about the successes they've had after leaving the University of Rochester. And these statistics that I'm showing are engineering and applied sciences specific. Our students do not want to stop going to school. They cannot get enough coursework. I wanted to show you let me talk about the difference between the master's and PhD versus the master's is usually like a year-ish. A lot of students want to keep going right after they graduate from undergrad, because at that point, as a student, you'll be in the best shape you've ever been in terms of being able to handle a wide variety of things. And instead of going out to the industry and working and trying to multitask and do your degree, some students just go right into it. The PhD, you don't pay for, it actually pays you. Most of our PhD programs don't charge you tuition. And engineering PhDs can be shorter than some of the arts and science and social sciences programs. Natural sciences are definitely shorter than a lot of the arts. An example of a professional degree is like a master's or a master's of business administration. You could potentially take at the Simon School of Business. We also have the TEAM program, Technical Entrepreneurship and Management program. That is one that combines both entrepreneurship in business and advanced instruction in engineering. So let's say, for example, you're a chemical engineer, you could do part chemical engineering and do part business in the TEAM program. So I wanted to open it up for the final questions. This is the contact info for the individual departments. I've also done our social media for the QR codes. Hopefully they work. They worked when I set this up. There's a lot of people that are involved in this, both between faculty, staff, and students. So with that, you're going to have questions. Please feel free to reach out to us. We really like answering questions so that you have all the information that you have before you make these decisions. Does a PhD require you already have a graduate or master's program? I let Paul talk a little bit about this. The answer is no. You have programs where you can earn a master's degree on the way to the PhD, but we have a lot of students who are accepted in their senior year into PhD programs and then start their PhD program the next year. Is there anything else I missed, Paul, on that?
No, that covers it. That's good.
Are there on-campus jobs available within the Hajim School? I realize that we don't really have, I think it's on one of the slides, we don't really have that. Yes, we have both federal work study and non-work study jobs on campus. think of federal work study as like this, is that the government provides funding to help pay up to half of the cost of someone's job on campus, right? So if, let's say, the financial aid office has a undergraduate working there, it's made possible by funding that the financial aid office has, and also from the federal government. So not all jobs require work study. There are a lot more that prefer it, but we typically don't see a problem with students working on campus. We try to limit it to fewer than 10 hours if possible, because especially in the first year, it's a lot of transition to college and everything is a lot different. So we don't want you working so much that class becomes more difficult. Talk more about, already answered. All right, good. The senior projects. The senior design is also something we can probably go into more depth in at some point, where students will complete a project, typically with an outside vendor, that wants you to solve problems, and you do as a group as seniors. It's a really good example of the complexity of group dynamics, but I have found that almost universally students have said this really prepared me for my job. When we talk to them, when they actually go out to into industry, they said that the senior design project actually helped me the most.
Let me just real quickly, I put the web address into the question and answer session, but if anyone's interested in seeing what kind of projects people do for Senior Design Day, if you go to the U of R website and type in Design Day, you can pull up a senior design page, which has essentially all of the projects for the last 2 or 3 years on there. You can get a real good feel for the kind of things that students do.
Yeah, I mean, I think that was another great byproduct of not everyone being on campus in COVID, that we have this list of former projects, and you can see, I mean, some of the projects are really how something very simple can be solved with or how something complex can be solved with like a more simple solution. The senior projects have been really great. Why are some engineering programs not accredited by ABET? I can answer some of this. As I said, computer science actively chooses not to be accredited because their idea is that they understand what you need to do to be a computer scientist when you graduate from here, and that their flexibility that they can by offering different coursework as it emerges. So think about AI now versus 5 years ago. So they may have had to go through more accreditation, jump through more accreditation hoops to introduce this new coursework into, which could be elective or a track for their students. So some of the answers, it is because they choose not to. In terms of something like engineering science, well, as you're not being a day-to-day engineer, you don't really need the accreditation from an engineering body, because the idea is that for you to be able to work in the field, which doesn't need to be regulated as much as an engineer needs to.
Let me hop in real quick. Just
Thank you.
In terms of engineering science ID, so the accreditation, typically it takes place through the professional society. So the Chemical Engineering Professional Society helps set the standards for a chemical engineering degree. If you go to an engineering science or an IDE degree, by their very nature, there's an A society, because they're very broad and they're design your own kind of program. So there really isn't any way to have those accredited. Computer science, just customarily, computer science programs are not accredited. Some are now, but traditionally they're not accredited. The big advantage of being accredited is, for example, you become a professional engineer. So if you want to become a certified professional engineer in most states, you need to have a degree which is accredited. So things like a chemical engineer, mechanical engineer, electrical engineer, it can be pretty important to come from an accredited department.
And at the end, in addition to commencement, graduation, you get to participate, if you're in an accredited one, in the Order of the Engineer, which is a ceremony where you officially become an engineer, which is very fun to participate in. Any other questions that anyone can think of? I know that was a lot of talking. As you can see, there are a lot of different parts to this. I think one of the things that we want to communicate is that, you may have an idea of what you want to do, but we have all these resources to help you either narrow that down or to really help decide if this is the way that you want to go. I do encourage you to look at the grand challenges and really see if your intended major matches up with the grand challenges. If you can start drawing the point A to point B between your expected major and then the problem you want to solve. I think that has provided people with a lot of context to be able to make these decisions. Any other questions? All right. Like, do you have any other information that you had to give them, the next steps or anything like that?
No, I would just add that, as Nick has said many times, we're very open to answering questions. Anyone that you see on the screen right now, I'm sure would be more than happy to answer questions you might have. If you can't remember the names, you can look on the view of our website, find the Hajim School, and you can, because all the faces here will appear on the website, and we're more than happy to answer questions.
Oh, one more thing too. So if you're not really sure what one of the areas are, we have a video series called the Full Spectrum series. It details what each of the majors are in more depth. They are available on our Facebook page, and some of them are on Instagram, and they're also all on our YouTube page. So if you think you want to be a biomedical engineer, but you really don't know what that entails, we have professors give a briefer introduction to this. And then we do a little Q&A to have them understand how they went from a senior in high school to being a professor.
As a plug, the mechanical engineering one is particularly well done.
It's excellent. It's by far the best. E5. E5 program. You could talk
I can answer what the E5 program is. Yeah, so E5 is not just specific to engineering. So this is both E5 and Take 5 are tuition-free fifth-year programs at the University of Rochester that students would apply for during, it's usually end of their junior year, beginning of their senior year. So E5 is the experiential fifth-year program. Take 5 is the more academic flavor of the two programs, but it's not an extra degree or anything. It just gives students an extra tuition-free year opportunity to do work in something that they are interested in on campus. So for the E5, oftentimes we see students, maybe it's so they can, incubate their startup, or they can go and get, seed funding for their business idea, or so they can do a service project, or do some kind of maybe unpaid internship type work, where they can use all of the resources at the institution to help with that stuff during that extra year on campus. So you might see some students doing engineering type stuff with that, but it really spans the whole range of academic disciplines.
We have one more question. Hajim, it's a very good question. Is computer science less math heavy compared to the other engineers degrees? There are two options that you could have within computer science. You can do the BS, or the Bachelor's of Science, or the Bachelor of Arts. The Bachelor of Arts, you can actually get through with only taking Math 150. So one course you could potentially take and be done. A lot of the students will start with Math 150, the introductory course, and then they'll take the calculus after that. So to answer your question, if you do the Bachelor's of Science, it's this around the same amount of math courses you'll take in the engineering courses. If you do the Bachelor of Arts, it can be one course and you can still graduate. Where can I find the recording of this webinar for future reference? Yeah, we can upload it to the page. I know it does. It lives in the admissions one, but we also could add this to our the Hajim YouTube page.
Yeah, I believe we have a bunch of these listed in our, I believe it's our admissions YouTube channel, but I can go and double check that one. I want to end Q&A there because I want to be respectful of the time of our panelists here today. Thank you to you guys so much for taking the time out of your Friday evening to chat with students and to answer. I think we're on 78 questions.
That would be a record.
and give this wonderful presentation. So it's really wonderful having you all helping out with this. And for the students or family members who have hopped on this evening or morning or afternoon, wherever you are in the world, thank you so much for coming. Thank you for your interest in the University of Rochester. I'm going to put the email address for our admissions office into the chat. I think everyone will be able to see it. It's just admit@admissions.rochester.edu. Please, any admissions related questions or admissions requirements questions, do direct any of those to our admissions office and we'd be happy to help. So if there's nothing else from anyone else on the panel, anyone have a word that they want to end on?
Have a nice weekend.
Yeah, Meliora.
Thank you, everyone. Meliora.
Meliora. All right, thanks everyone.
Bye-bye.
Bye.